Hello, in this video, we'll be looking at the pulley systems. Now these pulleys, they fall under simple machine. Before we go anywhere, we need to know what a simple machine is. So in short, we are looking at simple machines, and one of the simple machines that we'll be looking at is a pulley. Now a simple machine is a machine, usually a small device, so a machine or a device which makes work easier. It's a simple machine. Now how does it make work easier? By applying a small effort. So you really don't have to put a lot of effort in order for this to do work. No, you only have to apply a small effort for this machine to do its work. We go to our topic, which is pulley. Now a pulley is a simple machine that has got wheels, we call them wheels, and loops. It has got loops. There's also what to call a block and a tackle. So what a pulley system actually what does is, here there will be effort, then this will be the load. An example of a pulley, it's a crane. For example, if we put bags of maize here, then there's a crane lifting these bags of maize. So this loop will attach to the bags of maize, then it will pass through a wheel like around there, then the crane will be pulling this side. This is also an example of a simple machine or a pulley system. Now let's look at some terms that we can encounter on the pulley system. One of them is the mechanical advantage. Mechanical advantage, which is the ratio, so MA is equal to the ratio of the rod to effort. So the ratio, in case we are taught to find mechanical advantage, is the ratio of the load to the effort. Another one is velocity ratio. Velocity ratio, VR, is equal to effort distance, or the distance moved by the effort, divided by the effort, the road distance. All these are ratios, so they have no units. That's what you must know. Then also have what we call efficiency. Efficiency is equal to mechanical advantage over velocity ratio times 100, or efficiency is equal to road times the road distance over effort times effort distance. So make sure you are following what I'm doing. It's not always that you'll be given mechanical advantage or you'll be given 10 times 100. So whatever is just up here is the same as what is here. Whatever is here is the same as what is here. and must be out of 100. Let's look at an example. Let's say a load of 400 newtons. Let's call it the load is being lifted by a crane of through a distance. That is a load distance. Let's call it a load distance to be 15 meters. This is LD, load distance, by an effort. Let's call it FE of 100 newtons. Yes, just like this. So this is a load being lifted through a distance of 15 meters and an effort of 100 newtons. Question 1. How can we calculate the mechanical advantage? So mechanical advantage is equal to load over effort. And load is 400 newtons and effort is 100 newtons. So what do you get? You get 4. Units they cancel. That's why I said these are ratios, they don't have units. Question 2, calculate the distance moved by the effort. Now we know that for us to calculate the distance moved by the effort, we need to have effort. We need to have, okay, let me not put the distance moved by the effort, but let me say how can we find so let's say it also has a velocity ratio, let me say of 6. Let me say it has a velocity ratio of 6. So this is the information that we have about this Pulley system. Load, effort, distance moved by the load, and velocity ratio. So finding mechanical advantage, we use this. How can we find the distance moved by the effort? Now to find the distance moved by the effort, we'll say velocity ratio is equal to distance moved by the effort over distance moved by the load. Velocity ratio we have is 6. Distance moved by the effort we don't have. Distance moved by the load we have is 15 meters. Therefore, distance moved by the effort will be 15 times 6. That should give you 90 meters as the distance moved by the effort. Then next, how can we find, in case we're asked, how can we find the efficiency? So we know that efficiency is equal to mechanical advantage over velocity ratio times what? 100. One thing that you need to know is that mechanical advantage shall not exceed velocity ratio. So mechanical advantage we have 4. Velocity ratio we have 6 times 100. So 4 divided by 6 times 100, you have 66.66. You can just 66.7% as your efficiency. Now there's a question which they usually ask: why is the efficiency of a system not 100? Why not 100? It's not 100 because 1, some of the energy is lost. So energy lost through heat, through sound, also through friction. These are the main reasons: through heat, sound, and friction. That's why the efficiency is not 100%. So thanks so much for watching. I'll see you in the next video.